Alright, following up on our previous video, I just wanted to show you a quick example of how we can use the trapezoid rule to approximate a definite integral. So here I'm going to use it with n equal 4, which means I'm going to have 4 subintervals, and I'm going to approximate the integral from 0 to 2 of x cubed dx. Here's a quick sketch of the function over the indicated interval. And when I draw in the trapezoids, this is what it's going to look like. So at this point, you see that we have our delta x is going to be a half in this case. And I've also got a right triangle here. So basically, you can think of that as just a trapezoid with one base equal to 0. So at this point, you have a couple of options. You could just calculate each region individually or just utilize the formula. And I'm going to use the latter. So utilizing the formula that we derived in the previous video, 4 subintervals gives me this, and replacing each of those values with the appropriate values from the x-axis. And note that in this case, the function f we're referring to is x cubed. Substituting in for f at 0, f at 1/2, etc., we get this. And so when we clean up that arithmetic, the estimate that I'm getting for the integral from 0 to 2 of x cubed dx is about 17/4. This is an overestimate since the function f of x equals x cubed is concave up over the interval from 0 to 2. So the trapezoid areas are going to be a little bit more than the actual area under the curve. And when we do part B using antiderivatives, we will see that we'll get something a little bit smaller than our estimate here. So the actual area under the curve using antiderivatives produces an answer of 4. And so you can see I was off by about 1/4 or 0.25. So again, pretty good estimate just using areas of trapezoids.